Hi guys, right. So the last part of workbook 3, or technically session 8, right? The last bit of session 8 is on this thing referred to as learning curves. And as you can imagine, what we're really talking about here is that as you do something more and more, you get better. So the first time, I mean, I still can't ice skate, just because I just gave up. I just never went through the process of actually trying to learn. So that's what we're talking about here. So we're talking about learning curves. So let's go. So what and I think this is quite normal. You would agree that in especially when we're making standard products, this won't really work with complex or individual products every other day, because you have to relearn. You have to spend the time learning it, and then suddenly you have a new product that you have to learn again. But in an environment where you're pretty much doing the same thing, what they've noticed is that, of course, that as you spend time doing something, there is a tendency for labor time per unit to reduce, right? I mean, that just kind of works. You're doing the same thing. The first time you do it, it's tricky. The next time you get better and you get better and you get better and faster. So as more of the units are produced, workers become familiar with the task and get quicker. And really, this was really due to an observation made with aircraft production during World War II, that the rate of improvement was so regular that it could be reduced to a kind of formula, if you like. So we could almost predict what that learning curve rate was, because with good observation, you can keep records, right? By just observing the time it takes people to make things from when they join the production line, up to a certain time over a period of over whatever, 6 months, or then you can see that. I mean, again, you can imagine there comes a time when it becomes quite steady as well, where there is no further learning. In fact, it becomes frustrating, and there's actually an additional cost. So you can even measure that. It almost gives you an idea of how to plan what you do with people in terms of succession, so that they don't become a hindrance to the production line. So typically the argument is that the first time a new operation is performed, both the workers and the operating procedures are untried. And as the operation is repeated, the workers become more familiar with the work, and labor efficiency increases, and the labor cost per unit declines, right? You would expect that. So again, here, let's just say that if I'm paying someone £10 an hour per hour, right, to make a table, and they're spending 1 hour making the table. Now, imagine now that they because they've spent this time learning how to make the table properly, they now spend, um, if you like, in the next hour, they make two tables. So I'm still paying them £10 an hour, but they've made two tables in the second hour. So I've gone from a cost per unit of 10 over 1 in the first hour to 20 over 3 in the next hour, which is, a much lower figure. So labor cost does fall as you get better, as you can imagine, um, if you like. Now, this is the rule, and it's something we have to just work with, and it's actually very straightforward. But it's about watching what we're talking about here. So what I also want to say is, you want to always put a little table together. You want to follow the table, follow the rule, and you're fine. It really is that straightforward. And what they observed was that as cumulative, so this is additive, as we're adding and adding and adding, as cumulative output doubles, what I want you to almost underline here is this idea of the average. They observed that the cumulative, as we grow, of course, the cumulative average time, it's the average time I'm interested in, it's the average time that falls, if you like, to a fixed percentage of the previous average time. So it falls to a fixed, that same percentage of the previous average time of output. Very straightforward, and we'll see what I mean. Right. So what we now have is we now have this fall. So this average time is I highlight this again, is the average time that's falling, if you like, as we produce more and more units. It's the average time that is falling. So, for example, a 90% learning curve means that each time cumulative output doubles, the cumulative average time per unit falls to 90% of its previous value. That's what we're trying. You can see me I highlight here. Always create, always create a table. So let's come out of this and come to you. Um, come to the where are we? Let's come over here. Yes, let's come to our text to kind of highlight what I'm talking about here. So um, let's look at an example here, and literally, please just literally follow what I'm doing here. So we have here a labor-intensive production process has just been introduced, and the first unit took 10 hours to produce. Sorry, you might experience a blip there. I was interrupted and I had to pause the video. Right, so I was talking about an example here where you have a labor-intensive production process that's just been introduced. The first unit took 10 hours to produce. So it says here, historically, it has been shown that workers demonstrate a 90% learning factor. Let's just see what that means. And you'll see what I mean by always create a little table. What this is saying is that when you make the first units, just walk through it and just say it out loud. It took 10 hours to make. So if it took you 10 hours to make the first unit, the total time to make the first unit, of course, must be 10 hours. The rule says that every time cumulative production doubles, so after we go from 1 to 2, there is a percentage that the previous time falls to, or if you like, the learning time, the time it takes, the cumulative average time falls by a certain percentage of the previous time. So in this question, it's saying it falls to 90%. The cumulative time falls to 90% of the previous time, the cumulative average time. That's what it's telling us. That's the relationship of that curve that I showed you earlier on, right? This is as output, this is cumulative time falling. So that cumulative time falls from 10 to 9. 90% of 10, they'll always, well, when I say they'll always, there's a relationship. So that's 9. So that means that the average time, which means that what they're saying here is that for two products, the average time is now 9 minutes or 9 hours, sorry. So if the average time is 9 hours for 2 units, the total time for 2 units must be 2 times 9, which is equal to 18. So the total time for 2 units is 18. The total time for 10 units, sorry, for 1 unit is 10. Now you can see straight away what's going on here. It means, right, that the time it took to actually make the second unit must have been 8. So I made the first unit 10. I've made the second unit for 8. The total time, of course, is 18, and the average time, therefore, must be 9. So what's really important is to be careful to put your table in such a way you have cumulative time, the units, and the average time next to it, because that's what the percentage relationship is about. Let's look at this. Let's carry on and look at the fourth unit. So when cumulative production doubles again, so from 2 to 4, again, the average time is based on that percentage. It will fall to 90% of the previous time. So 90% of 9 is 8.1. Exactly the same principle. So I have 8.1 as an average. I have 4 units. So that means the total time for 4 units must be 4 times 8.1, 32.4. And I could keep going. 4 doubling to 8. 90% again of 8.1 is 7.29, and I have 58.3. So typically it's just dependent on the question. The question could ask, how long does it take to make the first unit? How long does it take to make the second unit? Well, you'd be like, okay, right. How long does it take to make the first 4 units? Well, that's the answer, right? 32.4. How long does it take to make the first 8 units? Well, that's the answer, 58.3. So let's see. So you can see here. Look at this one. This question could ask, how long does it take to make the first 4 units? That's that. How long does it take to make the next 4 units? So that means that's unit 5 to 8. So that must be the difference between 58.3 and 32.4, which is 25.9 hours. I think the key thing with learning factor or learning curves is to understand this table for whatever question you're given. And when you do that, you can then take out the information you need based on the question. Right. So we can see, of course, that ultimately, if this percentage is less, then it takes less time, and so if the person we're faster. So it's more the fact that 90% is not. I mean, we're actually if this was 80%, we would have had 8 here, and therefore this would have been 16. So overall, so you can see the point is that as the learning factor, so to speak, falls, then this means we're taking less time to actually make this product. We're more efficient. So we actually want it to fall. We want it to go to whatever as low as possible so that we're making the goods as quickly as possible. Okay, great. Now we also have the other scenario where you might get asked to actually find the learning rate. So they'll give you the information and they want you to find the learning rate. And so this is pretty much, I suppose, really an application of maths, and you just have to do it carefully. This is where you have to walk carefully in your calculator and make sure you can find certain buttons that raise things to the power. Right. So here we are. It says, let's do this example. The time taken by workers on 2 new products have been recorded. So here is the oh, sorry, actually, no, I don't even need to do this one. This is just kind of illustrating what I was talking about earlier on, that once the learning rate falls more, one is working faster. This is what I'm actually interested in here, finding the actual learning rate, which is what you could be asked. So it says here the time taken by workers to produce a new product has been recorded. The first unit took 24 minutes. So I'm thinking, okay, unit 1 took 24 minutes. So the total time must be 24. So you're always putting the average in the middle and the units here. Always, 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 and then total here. Really important, right? And it says the next 15 units took, so the next 15 units, so all the next units up to 16. The next 15 units took 228 units. So that's the next, basically from unit 2 to unit 16 to 228 minutes. So the total time, therefore, for 16 units. So let me just go to the actual thing so you can see it here. The total time for 16 units would have been the first unit plus the 15 units, which would be 24 plus 228, which would be 252. So the total time for 16 units is 252. The average time would be, of course, 252 divided by 16. The average time to make a unit when we get to 16 is 15.75. And they're telling us there's a learning rate. So there's a certain percentage that when I say, I will call that percentage Y. I don't know, for example, right? I'm just going to call it Y. Doesn't really matter. So I will say that this is the same percentage every time. So the average time, if you like, to make 2 units, really, right, is Y times 24. Maybe it's 90% or 80%. That's what I'm saying. So that's it. That's it. Y times 24. Now, for the fourth unit, I'm saying the average time as well is Y times the previous unit, the previous figure, which is here, and this is Y times 24, right? I mean, it's just there. That's what it is. Right. Well, I'm just going to take out this Y. I mean, this is 24. Y percent, if you like, Y percent times 24, right? So if this was 90%, like you saw me do earlier on. If it was when we had the scenario when we had 10 minutes, I said it was 90% learning curve. So it was 90% times 10. So that was 9. And then it was 90% times, right? And it was 8.1. Exactly the same thing here. So this percentage times 24. Here, it's the same thing. Y times, well, that's that. So that's kind of what's going on here. And so here, what I now have here is Y times, well, this whole thing, which is y times 24. That's what's happening at 8. So it means that over here, 15.75, what I have now is y times all of this, right? Y times all of this. So what I'm in effect saying is that y, this y, times 1, 2, 3, y times y times y times 24 is equal to 15.75, which is what you see here, in effect. So if I carry on, this in effect is like saying y raised to the power of 4, right? Times 24 is equal to 15.75. So this means that y raised to the power of 4 is equal to 15.75 divided by 24. So what you need to do is to put in your calculator. So I'll just show you. It's just that I don't have a 15. I'm sure you will find it. 15.75 divided by 24 is equal to 0. This is 0.65625. So y raised to the power of this. So what you need to do is, I'm trying to find y. So I need to put in my calculator. I need to find the fourth root of y. I need to. It's like saying something like this. If I said to you that, oh, y squared was equal to 4, I'm asking you what is y. You would say, oh, and it's 2. Y is 2. 2 squared is equal to 4. The question is 2 raised to the power of 2 is 4. So the question is, you need to just find in your calculator your way of arriving at y, or if you like, finding the fourth root, if you like. So when I say y squared is equal to 4, in your calculator you would go, what is the square root of 4, right? Ultimately. So, and the square root of 4, I mean, this is the square root. So in a way, you're looking for the square root. But this time I'm looking for the fourth root. So I want to put in my calculator, I need to find your way of and I can show you. I just probably need to find a screen that has a calculator. And I can't, that's the thing, but you just need to find your way of finding the fourth root of y. So it's more about calculators, and you will see that when you find the fourth root of 0.65 625, you will get 0.9. But this is more a calculator thing. So just practice in your calculator how to find, if you like, the fourth root of this, right? And then you'll be there. You see, because yeah, and that's pretty much it. So you get 0.9. Your answer becomes 0.9. You see, because if you raise 0.9, well, ultimately what we're saying here is if I raise 0.9 to the power of 4, I will get 0.65625. The question is, how do I get this, if you like, in your calculator? Okay, great. I hope that's been helpful. And I will put links as to the questions in the booklet that you could practice to make sure you get comfortable with this process. Okay.